Okay, so problem 21 here. So a sample is chosen randomly from a population that can be described by a normal model. What sampling distribution model for the sample mean describes shape, center, and spread? Okay, well what's going to happen is if we take a sample from this distribution right here, this population distribution, we're going to get a sampling distribution down here. Okay, now depending on how large our sample distribution is, so this has a mean of mu, and this also will have a mean of mu. So the means would be the same, the center would be the same. Okay, so this would have this population distribution up here would be described by a normal model with a mean of mu and a standard deviation of sigma. So this would be like 1 sigma, this would be 2 sigmas, this would be 3 sigmas, and then -1, -2, and then -3. Well, what's the standard deviation going to be here? Well, the standard deviation is going to be sigma divided by the square root of n. Okay, depending on how large that sample is. Okay, now that means that this sampling distribution is described by the model n with a mean of mu and a standard deviation of sigma, our original population, divided by the square root of n. Okay, so the question is, what happens in B? What happens when this n gets larger? Well, what happens when the bottom of a fraction gets larger? Well, the standard deviation gets smaller. There's less variation. Okay, so if the sample size got larger, then this distribution would get narrower and narrower. So the center here is mu. The shape is going to be symmetric, or we can say it's normally distributed, and the spread is going to be, of our sampling distribution, is going to be sigma over the square root of n.